All right, last video of the chapter, special types of linear systems, or more specifically, when the variable goes away. Because sometimes you can be working through a problem and the variable disappears and something's wrong. We got to fix it. So, in math, true statements are something like 0 equals 0, -2 equals -2, or 3 equals 3. If we get to a problem and there is a true statement, 3 equals 3, at any point, that means all real numbers, which means any number, are solutions. Okay? Or if we're graphing, that means it's the same line twice. So something like y equals 4 is the same line as 2y equals 8, because it's just doubling both sides. So it's the same line written twice. Okay? If we have a false statement, 3 equals 0, -2 equals 5, 3 equals 7, something like that, that means that there are no solutions, or the lines don't intersect, which means they're parallel lines. So you need that for what we're working on. Alrighty. So here's a couple problems. Okay, let's look at this top one here. These are separate. I'm going to just solve for x. So I'm going to subtract 3x from both sides. And all of a sudden, the x's went away on both sides. And so I'm left with 0 equals 2. Well, that's a false statement, so there's no solution. Or this line and this line are parallel to each other. Okay, same thing down here on the bottom. We have 6x minus 12 equals 6x minus 12. Well, I hope you notice here, if we split this equal sign here, we have the same line on both sides. But if we go through the process, I subtract 6x, those both go away, and so I'm left with -12 equals -12, which means it's the same line twice. Okay, that's what we're working on here. So, going back to the type of problems we're working on before, I'm going to do the addition method for this one. I'll do substitution. Actually, I'll do substitution this one, addition the next one. So I'm going to take this one and I'm going to subtract 3y to do substitution. So I get x equals -3y plus 4. And I'm going to plug that into that equation. So I get 2 times -3y plus 4 plus 6y equals 4. So I get -6y plus 4 plus 6y equals 4. And some of you should already be noticing what's happening here. That's great. So I get -6y plus 6y equals 0. Well, those go away. So I'm left with 0 equals 0. That is a true statement. So it is the same line twice. Or another way we could say it is there's an infinite number of solutions, since the lines are on top of each other. Okay? So down here, I'm going to do the addition method this time. So I'm going to take this one here, and I'm going to multiply times -2, because I want that to become a positive 4x. So I get 4x minus 2y equals -6. So I get 0 plus 0 equals 0. That's a true statement. So this, once again, is the same line twice, or an infinite number of solutions. Okay? These don't happen very often, but you got to be ready for them if they do. Okay, I want you to try this one on your own. You can do substitution or the addition method and see what happens. Okay, I'm going to do the addition method here. I'm going to multiply times 3. So I get 9x plus 3y equals -3. So I get 0 plus 0 equals 0. So it's the same line twice. If you did the substitution method, you should get the same answer. One last one. Give this one a try. I'm going to do the addition method again, because that's the one I like more. So I get negative 4x minus 2y equals negative 8. So that goes away. And so I get negative 4y equals negative 8. Well, the variable's still there, so I can just solve this one normally. So I get y equals 2. And then I just plug it back into the equation. So this was not a special case. This is just a regular case. 2x plus 2 equals 4. Subtract 2. 2x equals 2. Divide by 2. X equals 1. So my answer is 1, 2. That's where they intersect. Okay? For graphing them, parallel lines means no solution. One line repeated twice means infinite solutions. So if you did the graphing one, that would work as well. Check the website for your homework. Short video.